Question 3.5. Let me read it out. Undiluted sulfuric acid, H2SO4, is a 98% weight volume solution. That's pure acid, right? What is the molarity of this solution? So I'm asking you to convert from percentage weight volume concentration to molar concentration, molarity, okay? And then I'd like to know how much water I would need to add to 100 milliliters of this sulfuric acid to create a 0.2 molar solution. And I've also said the molar mass of sulfuric acid is 98 grams per mole, so I don't need to work it out, right? Okay, let's consider this. So the first thing I've told you is that I am looking at H2SO4 with a percentage volume concentration of 98%. Right. Now, okay, we're going to do that. What does that mean? That means that I would have 98 grams of hydrogen sulfide in 100 milliliters of water. Right? Okay. I'm going to ask you to tell me how much water needs to be added to this in order to get a 0.2 solution. Right. So let's work out what this is in terms of molarity, molar concentration, right? And I know that the molar mass of H2SO4 is 98 grams per mole. Okay. Okay. So to do that, remember what this is. This is grams per liter, right? Sorry, that's wrong. This is number of moles per liter, right? So let's, first things first, let's times this. Let's divide this by the relative mass to get rid of the grams, okay? So I've got 98 over 100 milliliters times by 98 grams per mole. I'm going to cancel that. That's going to go to the top. That's going to give me, well, let's be careful here. 2 sig fig. That looks all right to me. Yeah, actually, these values are going to cancel as well. So I'm actually left with 1 over 100 milliliters, and that on top is moles. So I got units of moles per milliliter. I need units of moles per liter, so that is 1 over 0.1 moles per liter, which of course is equal to 10 m. Okay, and I've still got 2 sig fig here, I believe. Yeah, because even though I've cancelled them, these values had 2 significant figures, right? Okay, so my concentration is 10 m. That's high. That's really high. You should know that, okay? If you're in the lab and you see a bottle with 10 m on it, you should be staying the hell away from it, okay? Because if it's an acid, it's going to strip the skin from your bones, right? Very, very strong acid, which, of course, is probably why we're diluting it in the first place. And the question was, my brain is not working this morning, how much water would need to be added to 100 milliliters of this to get a molarity of 0.2? Okay, so it's actually 50 times 50-fold dilution, essentially. Okay, is that right? Yeah. So to do that, I'm going to use my good old friend C1V1 is equal to C2V2. Okay, and I need to know how much water I'm going to need. So I want to know what my second volume is. I know what this is. Okay, it's 10. I know what this is. It's 100 milliliters. I know what this is. It's 0.2. That's my target concentration. So I'm just going to do V2 is equal to, let's rearrange C1 over C2. And of course, that is equal to 10 times 100 milliliters all over 0.2. And of course, actually, that's 3 sig fig, I think. That's 2. And this is only 1. So I'm only going to be able to give you the answer to 1 sig fig. Actually, no. This is 2 sig fig. I actually put 0.0 at the end of it. 0.20. Phew. So do that calculation, and your second volume needs to be, I told you it was 50-fold, so 5,000 milliliters, and that's 2 sig fig, right? Okay, so that's my second volume. Now, I haven't actually answered the question. My question was, how much extra water do I need to add to 100 milliliters? So do I need to add? Well, that's going to be V2 minus V1 is equal to 5,000 minus 100. Okay, which is going to be 4,900 milliliters to 2 sig fig. So this is the answer down here. Okay, don't make that mistake in the exam. Okay,